Okay, so work in a steady flow process, we have seen how open system and closed system is connected, is it not, students? Okay, so the laws of physics are defined for a open closed system, correct? Laws of physics, whether it is thermodynamics laws or whether it is the Newton's second law, it is defined for a closed system or unit mass. Even laws of electromagnetics are defined for a unit mass. Okay, to convert it into unit volume, sorry, control volume, we use Reynolds transport theorem. And one of the ways in which Reynolds transport theorem can be applied is, this is for Newton's second law. Sigma F is equal to m dot into V2 minus V1 for steady flow. Make sense? Okay. Now, similar way, we have seen along a pipe section, we had seen how we can do that. And we have come up with this one. Delta W in is equal to VdP plus VdV plus GdZ, where this is W. W, work done on the system. I'll repeat again. Work done on the system is negative. Work done by the system is positive. And here, since we have taken everything is as work done on the system, we are going to take it negative. That is the work done. Okay. And that relates to change in the VdP, which is considered as, we will see what is that later on. Delta V square by 2, which is change in the kinetic energy and change in the potential energy per unit mass. Compare that with Bernoulli's equation. Bernoulli's equation is change of pressure energy of flow work. What is flow work? We will see later. Okay, flow work. Here we are saying F work. If you see here, F work is about work done by the external agency like pump, correct? And if you consider this one, okay, this thing is flow work, which is P into V per unit weight. So when you take head in Bernoulli's equation, it is nothing but energy per unit weight. Here it is energy per unit mass. All the energy per unit mass, that is pressure energy per unit mass, the kinetic energy per unit mass, and the potential energy per unit mass is equal to the work done per unit mass. Make sense? Any doubts still here, students? We have done a problem and we have seen it. Then we have seen the first law of thermodynamics. What is first law of thermodynamics? For any cycle of a closed system, the net heat transfer equals the net work done. Simple and straight. Direct question. Okay. Next, we have seen one problem and we had seen how to calculate the work done. Okay. Then we saw work done for a non-cyclic process. Okay. In a non-cyclic process, we have taken two closed cycles. One is 1A2B1 and 1A2C1. These two cycles we consider. First we take first cycle, then we take the next cycle, and we see that since A is the same and these 2 and 3 comes to 0, whether it goes from 2 to 1 along C or 2 to 1 along B, the change is the same. And that quantity, delta Q minus delta W, this way, this one, this change, delta Q minus delta W, the change is the same. So that means it does not depend on the path. If the change of a particular quantity does not depend on the path, then it is a property, correct? It is a property, or it is an exact differential, correct? We have done it last class, you remember, correct? So that exact differential is called, I said internal energy, cut it. It is not internal energy, it is stored energy. Make that correction. It is nothing but stored energy. This delta E is stored energy. It is better put only one cut to say that generally we make this confusion that we say it is internal energy. It is not internal energy. It is the stored energy. Now what is internal energy? We will see in today's class. Okay. Any doubts still here, students? Any doubts still here? No doubts? Can I proceed? Hello? How many are there? 13 are there. Can I proceed, students?
Yes, sir.
Yes, very good. Okay. So let us proceed. Okay. So what is, I hope everybody has got the link, or I have put it anyhow. Okay, this is one of the things what happens, because 6 p.m. link only we have to use. Okay, any. So here, what is the statement? The change in the internal energy, sorry, change in the stored energy, very important. The change in the stored energy of a closed system in a process is the difference between the heat transfer and the work done. Now let us continue with saying what are the stored energy, what are the forms of stored energy. Let us see one by one. Okay. Now in this class we will see the nature of stored energy. Nature of stored energy. Now if you want to consider nature of stored energy, first type of energy is potential energy. First type of energy is potential energy. How does potential energy comes up? When you take a weight from, say, W, from one datum, say Z1, to another place. This datum is arbitrary. This datum is arbitrary. Okay, arbitrary datum. From an arbitrary datum, I am taking from Z1. I'll push this same W. This is the same W. I will push it to Z2. So when I push it, the stored energy increases. Correct? How does it do? So if I say delta E, or delta E is the stored energy because of change in elevation. Change in elevation of the weight W is equal to weight, okay, of the body. Okay, the work done on the body. Work done on the body is equal to the work done on the body. Thinking that there is no heat transfer. Correct? If there is no heat transfer, that is equal to work done on the body. Correct? What is that? You can write integration of F into dz, whatever the change is there. Okay, that can be written from, if I say 1 to 2, if I say like that, then it will be, what is F here? F is nothing but 1 to 2 mg, right? F is the weight, force is the weight. Yeah, going against the weight. Weight acts here. Okay, and we are going against weight and elevating to a higher place, is it not? So it is mg dz, which is equal to mg into z2 minus z1, which is equal to mg delta z, or we can say, so delta E, that is potential energy, I can say this is potential energy. This potential energy is mg delta z, or I can also say, okay, I can say potential energy 1 or 2 minus potential energy 1 is equal to mgz2 minus mgz1. Only to understand, why did I do these things? To understand that energy, potential energy comes also because of Fd cos theta, or you can say F dotted with D, force dotted with D. What is the force? This one. What is D? It is going up. Correct? So this is F dotted with D. Okay? Makes sense? So when, see, if you see F, let us understand this again. This potential energy or work generally or energy is F into D. Now observe here, as you increase the elevation, what is happening? Work is done on the system, correct? When you increase the elevation, what is happening? Work is done on the system. Now let us see how do we do that. See, observe again. This is very, very basics, has to be understood very nicely. So if I take the weight here, so weight is in this direction. And what is the direction of ds? It is this direction is the ds or dz. Correct? So W is going down, the distance is going other side. So what is that? Directly you get minus only, right? W is equal to, sorry, work done, work is equal to, say, let us F is equal to mg, let us write it mg. What is that? Mg is the weight, mg is the weight acting, and where is gz? In the opposite direction. So you can say F is minus, if I take this as positive z, then where is the force acting? It is acting as minus mg k, correct? Dotted with dz k, correct? Makes sense? Makes sense, students? Let me put it in the next slide. Okay, let me put it in, let me put it over here better way. Okay, So let us say this one, write it nicely. Okay. So what is happening? W is equal to minus mg because it is going in the minus z direction. Okay. Into k because we are taking this as z direction. Let us take it as z direction. Okay. Then into dotted with we have dz into k. Correct. So k dotted with k is 1. So we get work is equal to minus mg dz or delta z. If we will put delta z, we will put it as delta z. Let us put this as delta z. So delta z. So what is happening? If the work, if you are taking uh, block from a lower height to a higher height, work is done on the system, so it is negative. Make sense? If it falls by itself, work is done by the system, it is positive. Getting sense, students? What is potential energy? Any doubt here? Very simple, but on these simple things only we miss. Correct? Getting it proper, students? Any doubts you can ask.
So here weight is the system.
Weight is the force. Making sense? Hello?
Yes, sir.
Weight is the force. Weight is in Newton, is it not?
Yes, sir.
Yes. Any other doubt, students? Write this down. Next, we will go with kinetic energy. See, everything has to be connected to the basic, students. Only then we can get things properly. Okay. The problem is we don't connect with the basics. And do not think that, sir, we have this recordings. So, sir, we will attend the recordings. Let us not attend the class. Anyhow, recordings is there. No, the time is not there, students. If you're preparing for 2023, then it's fine. You can do that. But not when you're preparing for 2022. We are actually around 1 month late. Okay. At least 1 month late we are in preparation. Why? If you are if you had good concept, then it's a different case. But currently our concept is also less. Our aim is PSUs only. Okay, we will not compromise on PSUs, correct? Yes. Sir, videos cannot be down. Yes, it will not be downloaded, Baba. Yes, 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 yes. I will not enable that option, Akhtar. I'm sorry. I hope you understand. Is it not? Okay. So you can see any number of times, but you cannot download it. But there are people who download it. Please do not download. Okay. Yes. Maximum sit in the class and see. Okay. Because what you get in the class is the best one. Direct live. I'm going to repeat as many times as I want, as you want. Is it not? You can go to the videos if you actually are really not well and or you have missed something because of very important thing, then please do it. And one more point, if you consider videos are available all over the internet just like that. Okay. What happens in the live class, there's a different effect that comes in the live class, students, okay, which is not there in videos. Let me tell you frankly, if you attend the best of the lectures from the best of the teacher in India in the recorded one, you will not get it, students. Okay, you may not clear. Okay, but a moderate teacher giving you live classes, that has a separate effect. You may see that the experience in the live experience is different. Just like a cricket match, a recorded cricket match is always not that exciting, is it not? Similar thing here also happens. Here you are interacting, your presence is there. That has an effect. Fine. Now let us go with kinetic energy. Kinetic energy. Okay. Now kinetic energy, when you say what is kinetic energy? Delta E, kinetic energy is nothing but delta E because of change in velocity. Because of change in velocity. Change in kinetic energy, change in stored energy happens because of change in velocity. So what is that? That is equal to work done on the body, correct? Work done on the body because of the change in velocity. What is that? That can be written as integration of 1 to 2 F force into change in the length. Or this can be written as integration of 1 to 2 mass into acceleration into dl. Correct? Mass into acceleration into dl. Now this we can write it as, this whole thing we can write it as mass we can take outside, thinking mass remains the same, into 1 to 2 dv velocity by dt into dl. Make sense? Now this can also be written as, m into integration of 1 to 2 dl by dt into dv, and this can be written as m integration of 1 to 2 v dv. Sorry, v dv. When you integrate v dv from 1 to 2, what do you get? You get m by 2 v 2 square minus v1 square. Make sense? So kinetic energy change in delta kinetic energy is equal to kinetic energy at 2 minus kinetic energy at 1, which is equal to m into v2 square by 2 minus m into v1 square by 2. Simple. How the kinetic energy comes, that is important. Make sense, students? Okay, so that's it. That's how kinetic energy comes. Now, similar to kinetic energy and potential energy, there are a number of other energies which are there. What are those? We will see one by one. All the types of energies. Then we will go to gate problems. There are number of gate problems on first law. More than 20% or 10 to 20% of the questions till now are from the first law itself. This is very simple, but sometimes we don't understand this. Okay. And in gate, keep in mind, students, 50% of the questions are very easy. Try to get that 50% correct, you can get into IIT, provided your CGPA is high. CGPA is important for the present third and fourth year students. I am going to tell you, CGPA is damn important. More CGPA, more better it is. So be on the good books of the professors. Why did others did not come? Our Sharon is there. Who's not there? Okay, anyhow, we don't have our Chetan Shene, Vivian, Shishir Ballal. It's okay. Done, students?
Yes, sir.
Very good. Okay, everybody done, is it not? Okay, now let us go further. Now, what happens? Generally, the stored energy is not just that. Okay, stored energy E is actually equal to, when you consider stored energy, okay, stored energy,
Sir, could you go to previous slide?
very much.
Sir, kinetic energy is also considered as stored energy.
Kinetic energy is also the stored energy. Yes, kinetic energy is also stored energy. Potential energy is also stored energy. Correct.
Okay, sir. Done, sir.
Correct. Correct. So stored energy, when you say, when you consider stored energy of a closed system, or stored energy is equal to kinetic energy, can be equal to E is equal to, we have kinetic energy plus potential energy plus we have magnetic energy. We have not we have not derived this, but still, okay, magnetic energy. Then we have electrical energy plus electrical energy, okay, plus surface energy due to surface tension. Depending on the application, we are going to take that. This surface energy becomes important in what is that called? Rayleigh Bernard and I forgot the name. Okay, leave it. Okay, wherever this one. Okay, minus solid distortion energy comes in our material science. Gibbs free energy they call. Okay, distortion energy, solid distortion energy plus molecular energy, molecular energy, which is called, this molecular energy is called the internal energy U. That means the internal energy due to molecules U is actually equal to stored energy minus kinetic energy plus potential energy plus magnetic energy plus so on. So this internal energy has to be very, very important. Internal energy and stored energy is different. Very important. This internal energy is only because of the molecular interactions. This internal energy is because of the energy stored in the molecules of the system. Molecules of the system, very important. Okay. Now, how is that? There are a lot of things. It's not so easy to say all those things, but let us put a general blanket. Okay. So another point here, we can say, let me write it in the next slide. Okay, all right, let me write it here. Okay. So now I can say for general, if I consider all the other energies are not there. Okay. For general mechanical applications, I can say change in the stored energy is actually equal to change in the internal energy plus change in the kinetic energy plus change in the potential energy. Correct? Or I can say, if I say E generally, stored energy with respect to some datum, if I say U is equal to initial with respect to some reference, which is considered zero, okay, with respect to some reference, okay, with this, okay, let it not be there, okay, okay, let me write it in the next line, okay, one second, okay, if the delta U is equal to U2, U minus U naught, let me say, okay, and delta kinetic energy is equal to kinetic energy minus kinetic energy naught, and delta potential energy is equal to PE minus PE naught, if I consider that, then, and considering U naught comma, considering U naught is equal to 0, KE naught is equal to 0, and PE naught is equal to 0, I can write E is equal to U plus KE plus PE. Make sense? Stored energy E is equal to U plus kinetic energy plus potential energy. Make sense? Or let us not have this. Okay, let us not have this. I'll write it in the next slide, students. Very nicely. In a separate fashion. Let this not be there. Okay. Write it till here. Let us write next slide. Okay. Next slide. Let us. Next slide. We'll write it neatly. Okay. Write it down till here, students. Okay. Tell me when you're finished writing. Now there is much more thing to understand here. Let us understand one by one.
Why kinetic energy is negative, sir? Can you explain once?
Why kinetic? Oh, I'm sorry. My bad. It is
Okay,
all
okay.
negative here. It's all negative. Minus, minus. Everything is negative. Internal energy is here, right? This all these things comes other side. Or we can say if I put a bracket here and then I can say plus here. Minus all the other energy. Learn students? Hello?
Yes, sir.
Yes, sir.
Please, you have to tell me students, okay, once you have finished. Simply I'll be there in that, okay? Fine. So now what happens? If I say internal energy E, we will have this as U plus, if I consider the internal energy U plus kinetic energy, I can say mv square by 2, correct? Plus I can say mgz. This is the total stored energy. So stored energy of any system with respect to any datum, okay? If I say with respect to any datum, how do I get to that datum? If I say delta U, when you say delta U is equal to U minus U naught, let us say. And if I consider delta mv square by 2, let us take this as mv square by 2 minus mv naught square by 2, and delta mgz is equal to mgz minus mgz naught. And let us take, let us assume, okay, arbitrary, let us assume u naught is equal to 0, v naught is equal to 0, and z naught is equal to 0. Then we will get this, okay? Then we will get this stored energy, okay? Similar way, E is equal to delta delta E is equal to E minus E naught, and E naught is equal to 0. Then we will get this together, okay? Then we will get this, okay? Now if you say per unit mass stored energy per unit mass, sometimes we tell stored energy per unit mass, this can be written as E by small m, E by small m, which is equal to, which can be written as E is equal to small u, not mu, small u plus v square by 2 plus gz. Very important, will be used a number of times, this one as well as this one. So stored energy includes kinetic energy, internal energy, and potential energy. Very, very important take, students. A lot of places we miss this. Okay, and this is for the closed system. Now there are some more things to be understood. Now the thing is that, sir, if it is a closed system, where is kinetic energy? Where is potential energy? You will ask me, is it not? Correct. So what happens? Kinetic energy means the whole closed system is having a velocity. Whole closed system may be at elevation, and there is processes which is happening here. There is heat transfer Q, there can be work done W, both can happen. So when a closed system is moving, it is a unit mass. Keep in mind, mass can move. When mass moves, it has its own internal energy, it has its own kinetic energy, and it has its own potential energy. Make sense? When you say closed system, you have to consider a lump of mass. Making sense? Making sense, students? Now what is internal energy, what is this thing, all those things we will see one by one, okay?
Sir, could you explain that right side part once again?
Which
And network
slide?
issue.
Okay, see here.
Right
Now
side.
what we have done, we have put delta U. I can say here, in the sense of this one, I can say delta E is equal to delta U plus delta kinetic energy plus delta potential energy, correct? So here, delta U can be written as U minus U naught. U is any U with respect to some datum U naught, correct? Delta mv square by 2 can be written as mv, v is any velocity, minus a datum velocity, a reference velocity, okay? And if I assume that reference velocity is 0, Okay, means in a relative velocity term. Okay, if I use, because I cannot have, so I can have a zero velocity, but sometimes I need to have, suppose there is change in velocity. Okay, so you can consider something as datum. Correct. So if I take arbitrary, okay, u naught is equal to zero, because internal energy never goes to zero. Internal energy goes to zero only in absolute zero temperature. Okay, how internal energy is important, we will see one by one. V naught is equal to zero, Z naught is equal to zero. Similar way, delta E, we are taking E minus E naught, and E naught is equal to zero. Then we get this from here. Make sense? Make sense?
Yes, sir. Yes, sir.
And always it is a closed system, means you have to say a lump of mass which is moving. Okay, a moving mass will have kinetic energy as well as potential energy. Make sense?
Yes, sir.
And its temperature may change, correct?
Yes.
Very simple, but very, very important. This main thing, if we understand, a lot of things in thermodynamics will become easy. This thermodynamics, fluid mechanics are some of the subjects which requires a lot of mathematics, more than mathematics, conceptual understanding. And without mathematics, understanding cannot come, students. Okay. Tell me when you're done writing, students. Okay. But don't rush.
Also,
Over. Very good. Now, next point. Okay. Now, if you say a stationary closed system or a stationary, very important, for a stationary closed system or a closed system, or see, these are all very important terms, or a closed system which is a part of non-flow process, which is a part of non-flow process. So if there is a flow, you don't think it is open system. If there is velocity, if there is flow, do not assume it is an open system. Flow can also be a closed system, provided you go with the mass along with that. Okay, if there is a flow of something, okay, let me write it. For a stationary closed system or a closed system which is part of a non-flow process, we can say kinetic energy is equal to zero, delta kinetic energy is equal to zero. What's happening? Okay, delta kinetic energy is zero and delta potential energy is equal to zero. Then my Q minus W is equal to delta U. Makes sense? This is the first law. So for the first law becomes Q minus W is equal to delta U. Only for this, Q minus W is equal to delta U. Only for closed system, stationary closed system, very important. It can be called a stationary closed system or a closed system which is a part of non-flow process. I hope I'm making sense here, students. Or you can say Q minus W is equal to U2 minus 1. Let us do problems on this. First, concepts has to be understood. Then we have to see. Now, there might be flow, student. There might be flow. For example, a river flowing. And then I will say say in the river, there is a hot oil which has fallen into the river, and this hot oil is moving over the surface of the river. Now, will it be a closed system or an open system? This hot oil which is moving on the surface of the river is an example of a closed system, not an open system. Why? Because we are moving along with the closed system. We are not having a control volume here. What is that? The boundary is the oil drop boundary, the 3D boundary, whatever is there, whatever the shape the hot oil drop takes. And then there is heat transfer, then there is work transfer also.
That hot oil droplet is the control mass, sir.
Control mass, exactly, you're
Okay.
right. That is the control mass. It is a closed system. We are following the oil. And in fluid mechanics, that is called Lagrangian approach. It is called Lagrangian approach in fluid mechanics, which is nothing but, see, there is nothing called fluid mechanics and thermodynamics different. It is the same. So it's Lagrangian approach in both the case. Lagrangian approach is related to closed system in thermodynamics. In Lagrangian approach, we see fluid particles moving, or you can say closed system. Then if you consider control volume, what is that? That is Eulerian approach. If you say control volume, what is Eulerian approach? Eulerian approach takes control volume. In mechanics, in kinematics, we have seen, is it not, students? Lagrangian approach and Eulerian approach. Eulerian approach is about the control volume. Lagrangian approach is about the closed system control mass. Make sense? All the laws of physics are for closed system, are for control mass, not for the control volume. To convert the laws of physics, which is told for control mass, into control volume, we use something called Reynolds transport theorem. Okay, which I will derive in calculus, students. Okay, in calculus I will derive. Okay, in the morning classes.
Sir, when oil drop flows in river, there will be heat exchange of oil drop with surrounding also, right?
Correct. Correct. Yes.
So how we can assume it is closed system?
Why not? Heat transfer happens. There is no closed system. There can be heat transfer. There can be energy transfer. There should not be any mass transfer.
Okay, okay, sir.
Correct. Hot oil, when you say up, air is there. Okay. To the air surrounding is one half is air, the other half is water.
Yes, sir.
Correct. There is no water going inside the oil and no air going inside the oil. Correct. Because those are immiscible. Correct.
Yes, sir. If it goes, then it will have been open system.
No, even there you can say that the closed system boundary changes. That's it. The boundary can be flexible, is it not?
Yes, sir.
Closed system, we never say it's a rigid boundary. As the oil is moving, it may change its boundaries. It will not violate closed system, this one, closed system assumption. Correct? Hello.
Sir,
Yes,
if
sir.
it detaches, then two closed
It
systems.
detaches, yes, then you can say it is other closed boundaries.
If it oil doesn't mix, but if we use different liquid which is mixable with water,
Then no.
then
Then no.
then it's open system.
Then it is a, yes, it can be considered as an open system because it can go everywhere, is it not?
Okay, sir.
Things becomes a bit complicated then we will not say that, but generally we can say open system only. In interviews, these are common questions, students. Okay, this is a question which can come in PSU interview. A oil dropped in a river. Okay, hot oil dropped in a river. This is how it, see, what I am doing, I am preparing for an interview. Okay, so when the basics are clear, interview is cakewalk, students. Okay, because most of the students don't have the basics. You can see that your own classmates, you can see Do they know all these things? No. They might have first rank in VTU. But no, these concepts are not there. They might have 9.5, 9.9 CGPA. Concepts are not there. थोड़ा सा हिलाओगे तो सब कुछ धराशायी हो जाएगा. Okay. Shall we go further, students?
Done, sir.
Right. Next. Let us do a problem, students. Okay. A problem one. Problem. Okay. A quantity of gas in a closed system expands performing 34 kilojoules of work. Performing 34 kilojoules of work, while its internal energy decreases by 27 kilojoule. Determine the heat transfer during the process. Determine the heat transfer during the process. 1 minute question, students, please do that. Determine the heat transfer during the process. This is what is the problem we have. People search for jobs, just a job. They are very desperate for jobs. Okay, I say until you become good in your concepts, even if anybody recommends, you will not get a job. Okay, and even if you get a job, it's a small job. Okay, you will not make a career out of that job. Like Anil ji will tell you that. Anil ji, you're there? Anil is not there today. Okay, fine. Today somehow, I don't know why.
The 64.
64? No, wrong. Wrong. Basics. Let us understand again. What is Q? Q minus W is equal to delta U. Is it not, student? That is the way. So what has to be that Q? Q is what? Q is delta U plus W. Simple. Correct, students? Why are you not getting it?
Sir, it is minus 24 or minus 27, no?
Minus 27 because the work is the internal energy reduces. Performing 34 kilojoules of work. When it performs, work is done by the system. When work is done by the system, it is positive.
Yes,
Correct?
sir, 61. Sir, by the system, no, minus.
Work done by the system is positive. Work done on the system is negative. By the confusion. ನಾನು ಕೆಲಸ ಮಾಡಿದ್ರೆ ನನಗೆ ಪಾಸಿಟಿವಿಟಿ, ನಾನು ಕೆಲಸ ತಗೊಂಡ್ರೆ ನೆಗೆಟಿವ್ ನನಗೆ ನೆನಪಲ್ಲಿ ಇರಲಿ. मैं किसी से काम करवाता हूं तो नेगेटिव हूं मैं, अगर मैं काम करता हूं पॉजिटिव है मेरे लिए. मेक सेंस? करेक्ट? वर्क बाय योरसेल्फ, सेल्फ सर्विस 7. करेक्ट? 7 kilojoules of heat transfer. To the system or from the system, students? It's positive. Is it getting into the system or going out of the system? Can you tell me?
Into the system.
Into the system. Heat transfer, the temperature of the system increases. Correct? Is it counterintuitive?
Yes, sir.
It is counterintuitive. Why? Why it is counterintuitive? Work is done by the
By the
system.
system. By
34.
adding work will be done by the system if we add heat at the cost of internal energy.
Correct. Correct. Okay. So what is happening here? So what is happening? I'll tell you. Okay. So this one, yes, there is work going out. 34. It has gone out. Okay. 27 is the internal energy already there. If I don't add heat 7, then this will not come up. This will not add up. Make sense? Make sense, students?
Yes, sir.
Very good. Okay. Let us do some of the problems which has come in GATE. There are some simple questions. Okay. Okay. This is a question which has come in 1993. 1993 GATE. Okay. The first law of thermodynamics. First law of thermodynamics takes the form W is equal to minus delta H. Okay. Delta H, when you say it is enthalpy, let us not have that now. Okay. Let us have it later. Okay. Don't want. I'm sorry, students. Okay. It is related to enthalpy. Let us take it later. One second. Enthalpy, wait. So we have to do enthalpy only, then we will get some questions. Okay. Okay, there is open system, a lot of open system. Heat capacity. Okay, so we will go to heat capacity first, and then we will consider all the other things. We will consider enthalpy also. So what is the time now? Let us see whether what is the time now. Yeah, it's time, students. So we will do one thing. In the next one, we will go with the open system. In the second class, we will do problems later on because enthalpy is involved. When enthalpy is involved, one of the things what happens, we think enthalpy is just a type of energy. No, it's not energy. Okay. Why enthalpy is not a type of energy, we will see. Okay. So, yes, thank you very much. Okay, thank you very much.